Hi everyone, this is Sumant. So in this video we will just try to understand what is standard normal distribution. So in the previous video we have discussed what is normal distribution, right? So if you didn't watch that video, I just recommend you to watch that first so that you can able to easily understand the standard normal distribution. So yeah, before going to the video, so make sure to watch this video till the end, and also if you haven't already subscribed to the channel, make sure to subscribe and also like this video and also share it with your friends. So yeah, with that, let's start this. So yeah, standard normal distribution, right? So what is standard normal distribution? So standard normal distribution, in the sense, it's standardizing the normal distribution. For example, let's take let's consider this as normal distribution, right? So we just have the bell curve and this is how the normal distribution look like. So let's take this as normal distribution. Now if you just standardize this normal distribution, right, and if you just plot that standardized normal distribution, that is standard normal distribution, right? Now what is standardization? How can we standardize a normal distribution, right? So let's take this as mu. So let's take this as x1, x2, x3, x4, right? So let's take these 4 points in this normal distribution. Now to standardize this normal distribution, to make it as a standard normal distribution, first we should find the mean of this distribution, right? We should find the mean of this normal distribution. After that we should find the standard deviation, sigma, right? We already know how to find that mean and standard deviation. So after finding that mean and standard deviation, for each and every point, right, for each and every point we used to subtract that with the mean and divide it by the standard deviation. So for example, let's take this x1, right? So if you just find that, right, x1 minus mu divided by sigma. So this is how we used to standardize the data. So this process, right, what we just did here, like subtracting by mean and dividing by standard deviation. So we used to do it for all the points. So if you just do that, right, for example, we will just do like similarly x2 minus mu by sigma, x3 minus mu by sigma, and x4 minus mu by sigma. So what we used to call this, right? So this is, we used to define it by, like, we used to represent it using z, right? So here we used to call it as points when it is in normal distribution. The standard normal distribution, we used to call it as z score. That you should remember, like the points, normal general points in normal distribution. When it comes to standard normal distribution, it's the z score. So that's the z score. Z is equal to x1 minus mu by sigma. Similarly for all the points. Now if you just find the z score for the mean, right, we just have the mean here. Right? If you just find the z score, now the z score for the mean will be z is equal to mu, right? Mean is equal to, the point is mu minus, we used to subtract by mu and divided by sigma. So the z will be 0, right? The z score will be 0. So that's, we should remember in standard normal distribution. When you just standardize the normal distribution, the mean will be 0, right? The mean will be 0, and the standard deviation will be 1. The standard deviation will be 1. So that we should remember when it comes to standard normal distribution. So let's try to understand this with a normal data points instead of this x and y, like instead of x and mu. Let's try to understand this with a normal with some data points, right? So I will just try to assume normal 1, 2, 3, 4, 5, right? Let's try to assume that 1, 2, 3, 4, 5, these are the data points. And now you should find the standard distribution of this, right? Let's try to plot this, right? So this is the normal distribution. Now for finding the standard normal distribution, to plot the standard normal distribution, what we have to do? We should find the mu, right? What I have said previously. Mu is equal to, this is the sum of all the values divided by total number of values. So 15 divided by 5. So we used to get 3, right? Mu is equal to 3. Now let's try to find sigma square, like the standard deviation. So for this example, let's try to assume that as 2, right? Let's take standard deviation as 2. We just have standard deviation of 2. Now to find the standard normal distribution, what we can do is, so first let's try to find the third one, right? For this point, let's try to find the z score. like the z score, that's the 3 minus 3 divided by 2, right? So we used to get the 0. So I'm just plotting here the standard normal distribution 0, and similarly for this point 4, what we can just get is 4 minus 3 divided by 2, right? 1 by 2 is 0.5 minus 1, right? So this is the standard normal distribution here, right? I hope you understood, right? So we just have this normal distribution, we have just find the z score for each and every value, and this is how we can, so this is how the standard normal distribution which we just got here. So what's the meaning of this, right? What's the meaning of this 0.5? So what's the meaning of this 1? What's the meaning of minus 0.5? What's the meaning of minus 1? So these are all the z scores, right? What I just mentioned. So 0.5 means the point 4. So this is the z score of 4, right? The 0.5 is the z score of 4. So 4, the point 4 is 0.5 standard deviations away from the mean. It is 0.5 standard deviation away from the mean. And similarly, let's take this minus 1, right? So let's take this minus 1 is the z score of 1. So it is 1 standard deviation. It is also 1 standard deviation away from the mean, but it is on the left side, right? The left hand side. So that's why the minus here. So that's the meaning of this z score. That's the standard normal distribution. That's the that's how you can just able to standardize your data. But what's the use, like why we have to convert the normal distribution to a standard normal distribution? So for example, let's take when you are just having your data, right? Or when you have a data set, and when you have a data set, now when your data, for example, let's say this is x, y, this is x1, this is x2, right? This is x1, this is x2. So if you have these kind of variables here, now the x1 variable lies between like 1 to 5. The values are ranging between 1 to 5. For example, let's say x2 value ranging between 1000 to 2000, right? Let's take. So when you have these kind of variation, these kind of huge variations in your data, huge variations in the scale of the data, so this has an effect on the model, right? The model which you are just trying to build. So that's why when you just standardize your data, when you just bring all your data up from in between minus 1 to 1, so even for the model it will be easy for to learn the patterns, right? So that's one of the advantage. And the next thing is, so when you're just having standard normal distribution, we can able to find the probability. For example, let's take you just have this mean, right? So for example, let's take an example, right? So you just have in a class, you just have students, and the average height of students is mu is equal to, let's take 50, right? So this is and you just want to find, so what is the probability of the students, right? What is the probability of the students height is greater than 70, right? You just want to find the probability of mu greater than 70. So for that, what you can just do is, so this is 0, right? This is obviously 0, and this is similarly we used to have 0.1 and 0.2, and we used to have 0.7 right here. So now we just want to find what is the probability of mu greater than 70. So the probability of mu greater than 70 can be found using this standard normal distribution. So we just have the curve here. So probability of, you can just find the area under this curve, so you can just able to get the probability, right? So that's also one of the advantages. So this is what we used to do in z test. So yeah, right, we used to do in z test. We will discuss in depth in upcoming videos as well on z test. So yeah, these are the that's the advantage of standard normal distribution. I hope you understood what's the use of standard normal distribution, right? Why we have to convert the normal distribution to standard normal distribution. So yeah, that's all for this video. I hope this video is helpful for you. So if you feel so, make sure to like the video and also share it with your friends, and also if you haven't already subscribed, make sure to subscribe to the channel as well. So with that, I will see you in the next video. Until then, take care and thanks for watching.